One of the most difficult things for me to do personally with game development is animations. And this is not by any means the greatest animation in the world. In fact, he's walking slow. Look at it. I don't know. But this is my attempt at doing animations. As per request, the game now has animations. And in this video, I'd like to share all the source code with you and how to do this in Pygame. So let's get started. The basic concept behind animations is that you just have a bunch of images and then you just cycle through them. For example, this might be the first image, and then this is the second image right here. This is the third one, and then this is the fourth one. And then you just go and rinse and repeat, and you're good to go. The problem is that in order to do that, we would actually have to have 4 separate image files. And let's say that the player is moving in all 4 directions. Well, that gets really complicated because now we have to have 16 different images. So one solution to this is to have what's called a sprite sheet. Another term for this is a sprite atlas or a texture atlas, where you basically have you have one big image like you see here, and there's a bunch of sub images inside of it, a bunch of variations of the player, and then you pick different ones based on the animation you want to do. So that actually poses something else too. So if the player, for example, is facing, forward, we really just want to cycle through these 4 images and nothing else. And then if the player, for example, faces downward or backward, then we're going to cycle through these 4 images. And then let's say that the player stops moving, then we really just want to set the image back to this one. In our code, we're going to need to be able to load a texture atlas like this. And then we're going to have a separate class for handling the animations. And that class will have basically a list of all the images that it needs to loop through. Let's get started. For this video, we'll have new sprite sheets of players, and you can download them from my website here. The link is in the description below. I have the source code open from the previous video, which if you'd like to follow along, is in the description below. If you get stuck anywhere, or if you just like to download the source code, the completed source code is also in the description. We're going to add 2 classes to our sprite.py file. To get there, go into Source, Components, and we're going to go to sprite.py. Go ahead and scroll down to the way bottom of the whole file. We're going to start out with an Atlas class. This is going to be a sprite. So it's going to have everything that a sprite has. It's going to be able to basically render an image to the screen. However, it's going to be built to take in a big image and then divide it up into sub images. So we can actually load something like this, right, that you see with the trees. So, an image that may have a bunch of images inside of it. To create an atlas, we're going to take in an image, which is the file name that we want to load. We're going to take in the cell width and height. The cell width would be a single image. So how big a single one of these sub images is, the width left and right, and then the height up and down. In this case, for this image, the width is 32 pixels for one of these things, and then 64 for one of these images. The start X and the start Y represent which image that you want to load. So this would be 0, 0. This would be 1, 0. This would be 2, 0. This would be 0, 1, etc. So basically, you're telling the game like which one of these images do you want to start with. We aren't currently doing any logic yet for the animations. This is just for loading a sprite atlas. We can piggyback off of all the logic from the sprite class, so we can just call super init, passing in the image and whether this is UI. Which actually this is powerful because you could actually use this atlas class for your UI as well. Later in this class, we're going to end up changing the image because that's what's going to render. So we're going to keep a reference though to the base image, which is the entire image with all the sub images loaded into it. Image is going to be the specific image that you want, which we'll get into here in a second. We're going to go ahead and we're going to store the width and height and start X and start Y. And this is where we're actually going to create a surface that we can render into. So for example, we have this sprite sheet. So the base image would be all of these things. And then where it says self.image, we're creating a new surface. that surface would really only have one image in it at a time. And then as we want to change the image to something else, then we just, we'll be able to do that. We'll be able to render like this one, for example, instead. And, it'll draw that. So essentially what's happening is that you have the entire image loaded, all 16, for example, of these characters. And then you have another surface that only has one of them inside of it. And that one little surface, you can then render whichever one of these inside that surface that you want. That little surface is what actually gets drawn to the screen. So that way you're only rendering one thing at a time. Because of this, we're setting it to the cell width and cell height, which is the size of one single image inside of there. And then this will allow you to have transparency in that. If you don't have that, then you'll actually have like a background and it'll be a big rectangle. It won't have any transparency to it. This is where we're going to code a method called switch to. And this is going to be responsible for switching to some kind of subimage, taking in a X and Y in cells. So for example, we've got a couple images over here. So this is 0, 0. This would be 1, 0. This would be 2, 0. This would be 0, 1. So like the X and Y coordinate in cells, not pixels, but in images, of which one of these images do you want, right? So if I were to put 1, 1, it would go basically 1 to the right, and then it would go 1 down, and then that would be the image that it would render. So yeah, we're going to come in here, we're going to code that switch to statement. This will take in, like I said, an X and a Y in cells of which image you want to render. We'll keep a reference of which image that we're currently rendering to the screen. This is where we need to find the actual pixel X and pixel Y locations. So we're taking that cell X and cell Y and then just multiplying it by the width and height, and that will get us where the image starts. Going back to this thing, so this right here would be 0, 0. This here would probably be 32 to the right, so 32, 0. This would probably be 0x 64y. This would be 32, 64, et cetera, et cetera. So so basically the pixel X coordinate and then Y. And it always starts from the very top left, and then from there it goes from there. We'll come in and we'll clear out the entire image with fully transparent pixels. That way any other pre-rendered images into it will be cleared out. And then this is where we actually change the image here. So basically we're taking that base image, which is all of them, right? All 16 of those images. We're going to come in here and the actual location in the new the new image that we're rendering is 0, 0 always, right? That's the coordinate of the new image that we've got. That'll always just be 0, 0. We're just rendering into our image. But the location of where we're rendering in the base image, in that giant big where we're getting the pixels from, is going to change. So this is where we say, hey, we want the image at this specific location, like these pixels, right? So this pixel location here, and then 32 pixels and 64 pixels that way. So that is the really kind of the core of switching between different images. Now let's go ahead. One other thing that we need to do, and I'll show you, is in the image, you don't have to scroll up here, but in the sprite class, there's a set image function. And if the user calls this, then it's actually going to override the logic that the atlas is doing. So what we're going to do is we're going to sort of create our own set image function instead for the animation. We're going to override that. Let's go to the very end of the file. We'll come in here, we'll define set image just like we did in the sprite class. All we're going to do is we are going to ensure that the image that they want is actually loaded. And if it isn't, then we'll add it to the loaded images. We're then going to set this to base image instead of just the regular image like Sprite is doing. And then we'll just call our switch to function. So if the user ever wants to set a different image or whichever, then they can do that, and it's going to use the atlas instead. it's going to use the pre-defined cell X and cell Y, whichever the atlas was already using. Brilliant. We're actually done with this atlas class. So now this is where, because we have this, this is now where we can actually code animations. So we're going to create a separate class for this as well. And this is also going to be a subclass of atlas. I know we're doing, so sprite was the parent of everything, right? The grandparent. And then we've got atlas, which is the parent, and then animation, which is the child. So we have like 3 generations of classes here going on. The reason why we can do this is because we can use this atlas class later in case we want to switch, or use a sprite sheet and maybe not do animations or whichever. This is a couple different settings for animations, but again, the issue is that we don't want to just give it a list of images and then just, run through those. We want a little bit more control. We want to know which images that we're actually rendering over in a sprite, atlas. And then we also want to know how fast the animation is going to go. So we have this frames per image here. I'll leave this on the screen here for a second. Go ahead if you want to pause the video and copy that down. And then I'll show you what this frame coordinates means here. Have another look at this sheet for a second. Basically what we want to be able to do is say, this is the first one, this is the second one, this is the third one, and this is the fourth one. So what we're going to do is we're going to store, basically we're going to say, okay, the image at 0, 0 is the first one. And then the image at, let's see, so that's 1, 0 is the second one. The image at 2, 0 is the third one. And then the image at 3, 0 is the fourth one. We want all of these, they're all going to be tuples, right? Coordinate values. So this is x and y, x and y, x and y, x and y. And then all of these are going to be in a list. Basically what we're saying here is like, this is the first image that we want to reference. This is the second one. This is the third one. And this is the fourth one. By doing it this way, you don't actually have to have a reference to these images. And you can basically pick and choose which ones that you want. Another advantage of doing this is that you can actually just set one coordinate if you want to turn the animation off. So if you want to freeze the person in place at one of them, you can just pass in a tuple that has one of them inside of it. There are a couple other ways that we could perhaps do this, but for this video, I just want to show you this technique. I think that this is kind of the way I sort of prefer how to do it. So one issue with this is that frame coordinates really must have something inside of it. The thing is that frame coordinates, we really want the user to have to set this. So we really should actually raise an error if they didn't set anything in here. So let's come in here and let's raise an exception. If for some reason they didn't put anything inside of those frame coordinates, then we want to just raise an exception and just say, hey, you need to have at least one coordinate. To get the starting image, we just get the first set of coordinates, right? The first X and Y of whatever the first image is, and then we get X and Y here. So what we're doing is this first 0 here is which pair that you're getting, right? Which image. And then the second one is this one's X, and then this one's Y right here. Let's also keep a reference to our frame coordinates too as well. We're going to call our super constructor here. So the animation class really is not going to have to be responsible for drawing anything to the screen or anything like that. It's purely going to be sort of a coordinator to what image should currently be drawn. So it's going to instruct the atlas to say, hey, now I want you to switch to this one. Now I want you to switch to this one. But it's really not going to be responsible for any rendering on the screen. Let's come in here. We're also going to keep track of frames per image, which is how fast it runs, and then whatever the current image is that we're rendering, and then the ticks. Ticks is going to be used for basically keeping track of how much time has gone by. So that, let's say that frames per image is 10. The game updates 60 times a second, so that means that it's going to change to a different image 6 times every second. So because of that, ticks is going to increment by 1 every single frame, all the way up until it gets to 10 in this case. And then once it gets to 10, it's going to set the current image to the next one, and then ticks is going to go back to 0. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's going to just keep going like that. So we're going to tell the game engine to that we want to be updated, right? So the animation is actually going to have an update function. There's a reason for this, and in a next video or future video, I want to cover pausing the game. So this is one of the reasons why we're going to add it to updating instead. Normally, we could have just probably put this in the draw function, but I think this is good for now. So taking a look at the image again, if the player's walking, they're going to cycle through these 4 images. So let's say that the player stops walking. So now what's going to happen is this one right here is going to be the only image that's going to be set. So we need a way to dynamically set which set of images we want to animate through. I mean, again, if, let's say the player walks forwards, now we're going to have to switch to these ones. Or let's say that the player is walking to the right. Now, all of a sudden, we're going to have to switch to these ones right here, right? We need to be able to do that right on the fly. We need to tell the animation, hey, now you're going to do these 4 instead, or now you're going to do these 4. So coming down here, let's go to the bottom here. And we're going to create a function called set frame chords, which basically this function right here is going to, set to a different, set of frame coordinates, the different boxes that I kind of showed earlier. It's possible that you can set it just to 1 coordinate for if you just want it to be completely still, if you want to just go on 1 image and not have it animate. All we're going to do is reset everything. So we're going to set everything back to 0. We're going to set the new frame coordinates. Then we're going to get, similar to what we did earlier, we're going to get the very first image that's in that set, and then its X and Y. And then all we have to do is call the switch to function and just say, hey, switch to the first image, and we'll go from there. And this is really kind of the nice thing is, again, even though we're coding animations, we really do not have to put any logic in here whatsoever for actually rendering. This is more of just like a manager over all of the other drawing code that we've done previously. Our update function is what's going to actually control when it switches to the next image. So what we're going to do is we're going to add 1 to ticks every single time that it updates. And then if enough ticks have gone by to switch the image, then we're going to then we'll do that logic. Now, as a safety precaution, we're going to check if it's greater than or equal to. This is, in practice, it is possible, let's say that, frames per image is 10. It's possible that self.ticks in some way gets set to 11 by some means, right? Maybe later on we're, changing the ticks around or something and, some other class, and oops, we accidentally set it to 20 or something. Well, then it would never change. If you do greater than or equal to, that's kind of like a safety net to say if it's 10 or anything bigger than that, we're going to, we have enough to switch to the image. Kind of similar to what we did, we're going to reset the ticks. We're going to go to the next image. So we're just going to go up by 1. And then let's say that we're at the very last image. Again, using that less than or equal to here as kind of a safety net, then we're just going to set it back to the first image. To do that, we'll just set current image to 0. Similar to what we did previously, we're going to switch to the next image here. This is what actually switches it. We're getting self.current image here. So this is basically saying not the first image, but whichever image that we're currently on, we're going to switch to, and then its X and Y coordinates in the giant sprite sheet image. Perfect. And that's all of the code that we actually need to do in the sprite.py. So now it's really just a matter of making our player use this animation class. So before we code the player to, switch around and that sort of thing, let's go ahead and we're going to dive into source data, and then we're going to go to objects.py. And this is where now the player, right, instead of sprite, we're going to have to change that. Let's come up here and go to line 2 where we've got the sprite, and we're going to say animation as well. So we're going to take in the animation class. And then coming into this player, what we're going to do, let's make it a little bit neater here. So we'll just kind of open, yeah, there we go. And then what we'll do is instead of sprite, we're going to say animation. So we have that new image there. So we'll do player underscore sheet.png. Actually, it's player sheet2.png. And then what we're going to do, the cell width is 32. So each sub image is 32 pixels left and right. And then 64 up and down. Now frame coordinates, we're going to set initially to 0 and 0. And I know that's the default value, but that's fine. So this is also where you can say 15 here and set it anything faster than that. In fact, what I'm going to do is I'll come in here just so you can kind of see these. We'll do frame chords, and then we'll do, you don't have to do what I'm doing. And then, but it'll make it a little bit clearer as we're doing that. So yeah, frames per image. Maybe we want to slow it down a little bit and do 15. That'll do 4 images per second. Awesome. So this has been actually quite a bit of code. This is actually a good opportunity for us to test it. It's not going to animate yet just because we've set only one image here. But let's go ahead and dive into main.py and we're going to run it. Okay, and then we'll click new game, and there we go, and it actually runs. So you should have the player image here, and then yeah. So if you see a box around the player image, by any chance, I'll close this. Just make sure that in sprite.py, make sure that when you're creating the surface in the Atlas class, that you have this source alpha thing here. If for some reason you see a box around the player. The only other thing left to do at this point is to actually code the player to move in different directions. So let's dive into player.py. Let's scroll to the top, and where we see from component sprite, import sprite, we're going to come in here and also import the animation class as well. And we need to keep track of, number one is which frames that the player is going to do, and also the different directions. And one helpful trick that we can do is just declare variable names for these. So, you know, left is 0, up is 1, right 2, down 3. Doesn't matter what the numbers are, just as long as they're different from one another. This will make the code a little bit easier later on. Then what we're going to do is we're going to create each one of the frames for this. So I did these in the order that the images are in. So the down is the first one on the first row on the top. Then we have the up frames, then we have the right frames, and then we have the left frames, like so. For example, these frames right here correlate with the down frames right here. Perfect. And then the only other thing that we need to do is we need when the player is still. So the coordinates for those images are the following. We can just do a single coordinate. This will basically disable the animation, so the animation doesn't, you know, it doesn't have any other image to change to. So it'll just render one animation there. Let's go ahead and we're going to dive down to the constructor for player. Go to the very top of the constructor, and what we can do is we can keep track of which direction the player is walking in. Now this is where it gets really beneficial, right? Because we had that variable down that we set to whatever it was probably 0 or something. It really doesn't matter. You can just say direction equals down, and it knows, okay, I'm traveling down. And then self is walking equals false. So we're going to keep track of whether the player is currently walking or not. In doing this, I found that the code is actually quite repetitive for the walk animation. So because we're going to have to basically check and see if the keys are being pressed down, and then each time, you know, set a certain animation. So let's just create a method for it. Let's go right before the update functions. Find this update function. And what we're going to do is we'll come in here, we'll do def walk animation. Self will ask for a direction, and then we'll ask for frame coordinates. We're only going to change the animation if we walk in a new direction. So basically we're saying if the direction that you want to change to is not already the direction that we're walking in, then we're going to set the direction like so. We're going to come in here, we're going to set the frame coordinates. So we're telling the animation, hey, these are the new images that I want you to use. And then we're going to set self is walking equal to true. Again, all those images are already sort of, you know, loaded in there. That whole big sheet of images is already loaded in there. So basically it's just going to do a different combination of images to achieve the animation we're doing. Let's also do a stop animation as well. So we'll get a reference to the animation. We're going to set is walking equal to false. And this is kind of a trick to check that we're not already still, like we're not already not walking anymore, just so that we don't keep calling set frame coordinates. And then in this case, we're just going to loop through each one. So self direction, if the direction is left, then we're going to set the frame coordinates to the left still set of animations. And likewise for right, down, and also up too as well. So we'll set it to whichever one it is, and we'll go from there. Brilliant. So now what we're going to do is we'll dive into the update function. Let's come over right before we're checking for user input, right before this pygame.kw. And what we're going to do is we're going to have two new variables. So the future direction that you're going to travel in, and then also the future frames that we're going to do as well. We're going to initially set those to none. Okay, so what we're going to do is we're going to find each one of these user inputs here. There's 4 of these in total. So go ahead, we're going to find where it says W here. And we're going to come in here, and if we press the W key, the future direction is up, and then the frames is up frames. Come in here, we're going to do the same thing for the down, right? So if the user presses the S key, then they're moving down. So we're going to come in here, we'll do the following for this. The reason why we're doing this is because we don't, we're just setting references to things for performance reasons. We don't want to, we also don't want to interrupt the animation that's already happening if there is an animation that's already happening in that direction. So let's come in here, we'll scroll down to, the other ones are a little bit lower. So the A key determines whether you're moving left. So what we're going to do is we'll come in here and we'll set the direction to left and then left frames. And then the D key, we're going to set the future direction to right, like so. And then we get to the very end of all this. And so we're going to come right after the camera. And what we're going to do is we're going to check if the future direction was set, if the future direction was set at all. And if it was, we're going to call the self.walk animation, passing in the future direction and the future frames that we want to change to. Now, if we're already walking in that direction, then it's not going to set it. That's kind of the beauty of this. Now, if we stopped walking, we need to also stop the animation from happening. We need to make sure that we are walking in the first place and that we need to stop. And then we'll come in here, we'll do the stop animation. The reason why we're doing that, again, is just because we don't want to reset the frames every single time, just for performance reasons. Okay, so perfect. Now that we've done this, let's come into main.py, and we're going to test it all out. We'll see, let's run it. Go to new game, and now the player is actually walking in different directions. Very good. Now, one thing that you might notice is the enemy isn't walking in, directions like so. And one thing that I think that we can do in future videos with this is we should probably revise the combat system a little bit. Let me know in the comments your suggestions about combat going forward. What kind of ideas do you have? What would you like to see out of combat? Because currently, right now, the combat system, even though we've got different weapons and stuff that you can use, I think it's probably a little bit boring. So, before we kind of revise and do animations for the combat system, I want to kind of see what would you guys like to do for the combat system? What would you guys like to add to this? So, either which way, we have now successfully done animations. So, thank you so much. Again, if you get stuck anywhere in the code, all the source code is in the link in the description below. And thank you so much, and I hope you have a good rest of your day.